Hey guys, Miss Cochran here, and we're on your packet, page 21, learning about law of sines. Law of sines, notice they draw a triangle, ABC. Those are your angles, the big letters. Across from big A, the opposite of it is little a. Across from big B is little b, that's the opposite of it. And across from big C is little c. You should remember drawing that back in your geometry class. Now, notice the formula is given. It's sine of big A over little a, and it equals sine of big B over little b, and sine of big C over little c. Now, you don't have to use all three of the little ratios. You could just do the A and the B. You could just do the B with the C. Or you might just need, well, that's too much. You might just need the A with the C. You don't have to have all three of them, but it's showing you that all three of them are equal. Now, if we skip down to our problem number 1, let's show how to work this, okay? First thing is, when I'm setting it up, I need to see if I have the set of opposite, okay? So you've got to kind of look and say, okay, 52's with X, and 34's with the 10. So we can say sine of 52 over X equals sine of 34 over 10. It's kind of like we had A and we had B. So we did big A over little a, big B over little b. Now we would cross multiply to solve it. So when you're cross multiplying X times sine 34, I'll just write that, and bring your equals down, and then you go the other direction, 10 times sine 52. If we're solving for X and they're multiplying, then how do we undo that? Divide. We're going to divide by sine 34. If we divide by sine 34, the signs cancel on this side, leaving me X equals, and all of this goes in my calculator. Now, I like to type it with the, and I'm in radians. Let me fix my calculator back to degree. Okay. All right, so now I'm in the right mode. I would go 10 sine 52. Now, notice all that's on the numerator. I would go ahead and enter that. So that 7.88 is the top of the fraction, and now I would press divide that number by sine 34 and press enter. Our answer to this problem, you could either write 14.1 or did it say round to, oh, it did say round to the nearest tenth, or 14.09, just depending on where it asked you to round. In this case, it did ask for the nearest tenth. So 14.1 would be our answer to the side of that triangle. Now, I'd like us to look at number 3. And in problem number 3, do we have opposites? Okay, do you see any set of opposites? And what is it? Right, okay, we have sine 64 over 32. And it would equal sine of, we don't know that one, over X. So we're going to have to, in order to solve it, you can't have two missing items. You can only have one, so we've got to find that angle. Is there a way to find that angle? How many degrees are inside of triangles? 180. So if we go off to the side and take our 45, add our 64, that's 109. Well, we know the triangle should have 180, so we can subtract the 109 out, and we get a 71 degree for that angle that was missing. So 71 is the angle that was missing, and now I can do the cross multiplying. If I go this direction, I can do X times sine 64. The other direction is 32 times sine 71. Divide by your sine 64 to get X by itself, because that will cancel. And then this could be entered in our calculator. So going back to our calculator, it's 32 times sine 71. That's all on my numerator. I'm going to hit enter. And then divide by sine 64. My answer to this is 33.7 if I round to the 10th. And that's my answer for the missing side of that triangle. Now, to do a little small recap about this law of sines, guys, remember C1 hippie, catch another hippie, or your 45-45-90 rules, or your 30-60-90 rules? They only work when it is a right triangle. Law of sines works no matter what kind of triangle you have. It can have a 90, but it doesn't have to. And we just worked two triangles that did not have a right triangle. Neither of them were right triangles. So these two triangles, you could not have done the C1 hippie, catch another hippie. You could not do your sine, cosine, and tangent ratios with these because there's no right angle. There's no hippie, if you will. Now, look at problem 5. And they kind of set it up like it would be a word problem. They say Kevin, Adam, and Dan are passing a hockey puck. How far is Kevin from Adam? Okay, so we want to know Kevin to Adam right here. I'll call it X. I have a set of opposite. I see the 86 goes with the 25. So I know I could say sine of 86 over 25. But if I'm looking for X, I need Dan's angle. Okay. So can we find Dan's angle? Okay. We could add up the 71 and the 86. If we add up 86 and 71, we end up getting a 157. If we subtract that from 180, you end up with 23 degrees for that angle that's kind of by Dan. Now we can set it up and finish this problem. So we can do sine of 23 degrees over the X. Now we can do our cross multiplying. 25 times sine 23. Bring down your equals and go the other direction. X times sine 86. Because we're solving for X, we need to get rid of sine 86, and it was multiplying, so we undo that by dividing by sine 86. Sine 86 cancels, and then we enter in our calculator. Now, I know I've been kind of getting you to tally the numerator before. The reason for doing that, let me kind of type it wrong. 23 divided by sine 86. I just kind of typed what I saw. This is what it gave. What happens is we didn't close off our sine, so it kind of messed up the math, if you will. So this is really a wrong answer. To maybe make it better, we could do parentheses around the whole thing. Some students will do that, putting parentheses around the whole numerator. And then dividing by and maybe do parentheses around the numerator. I mean the denominator. If you do that, oh, it did do. Oh, it is a tiny bit off. Oh, that's kind of weird that it's that close in the answer. It is actually a different answer, although it looked kind of the same. So this one is just unique. Sometimes this will be really far off. So just to let you know, another way you could have entered it is alpha y equals and actually type the numerator on the numerator part of the fraction and your denominator where the denominator goes. Now, I still don't like leaving a parenthesis hanging opened, so I probably would myself close them. And you can see that the top answer really is incorrect. It's really hard to tell that because of the so it's so close in the answer. But that's kind of a fluke. That's not going to always be the case. So our answer, if we were rounding off, was approximately 9.8. And that is the answer to how far Kevin is to Adam. And it was in feet, so we might even add that this was 9.8 feet. They were apart. Now, if you will, turn to your page 22 with me, and we're going to look at a few more problems. It is still doing law of sines. That part isn't really changing. It just says, watch out when finding angles. It's impossible to have it is possible to have one solution or two solutions or no solution. They call this the ambiguous case. Important facts: sines function always has a range between -1 and 1. The sine function is positive, then the angle can lie in quadrant 1 or quadrant 2. That is talking about, remember how we do all students take class? Sine is positive in both of these quadrants, is what they're talking about. In quadrant 1 and quadrant 2, sine is a positive answer in both of those. It says to find the other possible angle, subtract from 180. The sum of the angle measures in a triangle always equal 180, and no triangle can have two obtuse angles because it would pass the 180 degree mark that all triangles have if there's two that are obtuse. So I have 3 that I want us to look at on this page. Let's start out looking at problem 7, and I will draw a picture. I'm a very visual learner, and so I like to have a diagram. I'll put A right here as 50 degrees. I can put B down here and C up top, kind of like the diagram was earlier on page 21. AB is 4, BC is 9, and it wants us to find angle C. So I'll just circle the one we're finding. So it's just going to set up the same way we did all the other law of sines. We're going to do sine of 50 over 9, and then sine of angle C over 4. We will cross multiply like before, so nothing really happens new right here. So if you multiply, go in that direction, you have 9 times sine C. If you go the other direction, you have 4 times sine 50. You would divide by 9 to get it away from your sine of C. I usually take that into my calculator now. So 4 times sine 50 divided by 9 gives us a 0.34046. I usually carry this out a long way because the longer that little decimal is, the more accurate your angle will be. Now, so I'm going to leave that in my calculator and show you something in our calculator. The next thing that I would do is multiply to get rid of sine. I'm not multiplying, but I'm going to do sine inverse. That cancels that one out. And that's what I will do in our calculator. Now, I want you guys to watch. That decimal is already in my calculator. I'm going to do second and then the sine button. That's that inverse part. Then I'm going to do second, and down here at the bottom of our calculator it says answer. I'm going to press this key. So I did second and then that little negative button, and it types all of this answer into that location. So press enter, and it gives you 19.9. Now 19.9 is one answer that is possible for the angle C. If you think about your triangle, could we have a 19.9, a 50, and some other angle? Yeah, it leaves room for an angle B to have some kind of number there. So this still would be okay. It's about 70, so this angle would be somewhere close to, and I'm just kind of estimating 110. If we were just kind of thinking about this triangle. But this is where they said, hey, this sign, where it's positive, it can happen in both of these locations. So if you think about the 19.9 is in this location, what is 19.9 in this side? Well, remember how we're 180 right here, and it would back it up that amount? That's why they said to subtract the 180. So you're actually going to do 180 minus that number, 19.9. So if we do 180 minus 19.9, we get that it would have been at 160.1. So 160.1 is the other possible answer for this problem. Okay, so, but can 160 work here? Well, let's think about it. If that's 160 and we already know that's 50, that won't work, will it? What is 160.1 plus 50? Oh wait, we can't have a triangle that has 210 degrees, can we? Okay, so what really happened is I saw the 160.1 degree, but I know that it can't work in this problem. Okay, so there is only one answer that would work for number 7. Let's check out number 8. Now I would draw a little diagram again. You don't have to draw it. I just think it's helpful. 37 is your B. AB's side is 47. AC's side is 29. And they want angle C. So if we're setting this one up, I would do sine of C over 47, and then it equals sine of 37 over 29. And I would cross multiply. So we end up with 29 times sine C. Go in that direction. The other direction, we are going to have 47 times sine 37. We would divide by 29. So we're going to get sine C equals, and I like to put that in our calculator like before. So 47 sine 37. Oops, hang on. I had accidentally pressed another key. So let me do that again. Okay, that's my numerator, and I'm going to divide by 29, and I get a 0.9753 number. I'll leave that in my calculator to use in just a moment. We've got to do the inverse sign. So I'm going to do blue key, sign button, blue key, the answer to plug that 0.97 number in. And we get an answer of 77 point, we can round it to 3. So C's answer is 77.3. Now, we do have to check it to see, could another possible answer work here? And this is where you're checking the two quadrants. We know 77.3 would lie somewhere in here. But what is it on this side? Okay, we have to take our 180 and do 180 minus that 77.3 number. And that's going to give you 100. So on this side, it would be 102.7. So now we have to kind of say, do both of these work, or is it only one of them true? Well, if I have 37 and 77, okay, what is 37 is one angle, and 77 we said 0.3. Okay, that still allows for more room for a third angle, doesn't it? For angle A. Okay, so that would be okay. So 77 is a good answer. Okay, Now we need to see, what about 37 and the 102.7? Is it also going to work? Well, does it leave room for angle A? Yeah, it does. Guys, this is a case where both of the answers can work. So what that really means is there are two triangles that are possible on problem number 8. Two different triangles. So A is going to have two different values, but the sides are still the same that they gave, and the angle B is still 37. So this is what they call the ambiguous case, when you have two correct answers for that angle. It doesn't happen a whole lot of times, but you will run into it. Okay? You just have to check for it. Let's look at 10. On 10, once again, I'm going to draw that little triangle. A is 114. Notice I'm not even drawing to scale. I just want a little diagram to look at. AB is 34. BC is 12. And we want C. Okay, so if we set this one up, I would do sine of C over 34 and sine of 114 over 12. I would cross multiply, so 12 times sine C, and then go the other direction. 34 times sine 114. Divide by 12 to move the 12 away from your sine of C. Put this in our calculator. And you get a 2.588. If you do your inverse sine of that answer, okay, we get an error message. The error message exists because if you think about our unit circle, don't we only go out 1 unit and up 1 unit and left 1 unit and down 1 unit? Well, this one's at 2.5. You're gone past. It gives an error message because it's just not allowed. So C cannot exist, which means, and I'll put a little error message in our calculator. It means it has no triangle that will fit this information. Okay? There's no solution to number 10. All right, guys, you are to finish pages 21 to 24, and let me know if you have any questions.